Hi everyone, and welcome back to Azure for Sure, episode 7 of season 2. I'm your host Simon, and we're back once again. If you're someone who's joining us for the very first time, in this show, we talk nothing but Azure, and it streams on every Thursday at 10 a.m. Pacific time, which means if you're joining us from the Asia, it's pretty late. Just like for me, it is 10:40 p.m. India. Last week it was 11:30 p.m. For some funny reasons, I don't know. The world decides half the world decides to change their timing, change their clock. We Asians, we don't understand how what that thing is. But yeah, there's been change in time for the rest part of the world. I think it is 1 hour ahead. So that is an update. Also, we're starting just 10 minutes late. So I'm not going to take a lot of time because today we have an absolutely amazing guest. I'm hosting him for the very first time. I cannot believe it. Or maybe I've hosted him. I don't remember. He's Peter. He's joining us from Seattle, Washington. He has an extensive background in architecting, deploying, and managing and training Microsoft technologies dating back to Windows NT4 Server 1996, a year before even I was born. and he's reallocated from Belgium to Seattle in early 2022 and is developing some great apps on .NET Blazor as a new hobby. You can find him on Twitter, that is PDIT, and he is a complete rockstar. So let's just bring him in. Hi, Peter. Welcome to the Azure for Sure live show.
Hey Simon, thanks for having me. How you doing?
Yeah, I'm doing absolutely great. Thank you so much, Peter. First, thanks for accepting the invitation. And second, how cool it is to have a snake on one end and a cute cat on the other end.
Every now and then they're fighting a bit, depending
I
how I
think
deliver my sessions. They're my control
I
animals.
yeah, I see. I am pretty excited about your session. First, I know that there's going to be a lot of slides, right? You're going to have a lot of slides in your session today, as you said in the tweet, right? So we are definitely looking for that. And second, it says chaos engineering for Azure workloads, right? Now, whenever we hear the term engineering, it gets excited when not many people put the word engineering in their session. To be honest, I've hosted quite a few folks. No one puts engineering in their sessions. I'm really excited. Peter, having said that, how about we do a lot of this chit chat towards the end, right? And I
Sounds
let
good.
you start with your session.
Cool. Let's see if we can share our screen.
And for all those who are thinking Peter is in his bathroom, right? It is not. Or are you? At what
No, no,
time is
no.
it at you?
It's dedicated office space. Can
I'm
you see the
kidding.
screen just to be sure
I see the
that
screen. I've added it to the
technology
stream.
works?
Everybody else can see it. And next 30, 35, 40 minutes is all yours.
Cool. Sound good. So what is chaos engineering? That's the whole thing, right? Now, I promised you in actually the latest tweet, like only a few minutes ago, like no slides. But then, funny enough, I actually received a DM like, how can you present for 35, 40 minutes without slides? So I quickly came up with a title slide and I wanted to integrate a little action for the audience, but I'll talk about it a little bit more towards the end. Now, it's not going to be a slideshow. I like doing demos, and that's partly what I'm going to do this session as well. But at least to show a little bit of a slide, I got like 5 of them, so it shouldn't take too long. Quite some information here about myself, but thanks for the nice introduction you actually did. Um, it actually made me feel old. That's the main thing. But I've been around in the industry for quite a while, and I could say jumping from one end of the IT industry all the way to the other, meaning building physical data centers like 25 years ago, providing cabling, cooling, everything that a data center needs. We're now all the way to cloud, where basically you're not even seeing a data center anymore. So I'm wondering what's going to happen in the next 25 years from now, but we'll see. Apart from that, been publishing a couple of books, which started as something interesting, exciting, and actually been doing it for like 8 years, about 10 years now, actually. And I would say watch over the one on the left in that list because it might be interesting for the end of the session. Now, what is chaos engineering? It's something new, but not that new. Actually, something that Netflix, I think we all know what Netflix is about. And their internal engineering team actually came up with chaos engineering already 10, 12 years ago. So what they were looking for is a scenario to test their production environment. So in short, there's obviously in meantime, there's an official definition. So it's about experimenting the stability, high availability, the resiliency of your preferably production environment to make sure that it can withstand any turbulent conditions as they describe it. In normal IT language, I would say hammering your servers, trying to break them down as much as possible in production to make sure that you learn from it. And that's mainly what chaos engineering is about. Now, if you think about like, okay, but what's the cool thing about it? I'll show you in the biggest part of the session, but there's a couple of things, right? So one of the first demos I'll walk you through is what I call the curious case of CPU pressure. What it means, and we all know because we're using it every single day, you have a virtual machine, you got a workload, you have a web app running in Azure or maybe AWS, Google Cloud, or anywhere on the planet, and something goes wrong with it. Like CPU spike is an easy one. You have some application, customers connecting to a retail website, for example. And we all know that based on monitoring metrics, you're going to find out how is my server behaving. Where we also all know that once my CPU spikes and it runs for 90% CPU load during X amount of time, most probably your workload will crash, right? It's going to restart itself. If it's a container, it's probably going to recover. But on a virtual machine, it's crashing, it's stopping, and that's it. Your production environment is down. So what you can do now is figuring out like how long can my workload survive during that CPU load? Or maybe we need to add additional servers and hoping that the platform can help us with that. But that's like an easy thing. Or the other one is the human being. I call it the DevOps engineer, but it's not specifically for DevOps engineers. But what it means is that the human being can also be the weak spot because you're missing metrics. You're not seeing them. You're, I don't know, facing a CPU spike like at 3 o'clock in the morning where everybody's supposed to be sleeping, right? And then maybe you're missing something where now your users or customers connect to the workload 8 o'clock in the morning and it's not working. So that's what we're trying to test against using chaos engineering. And then the other thing is that, like, okay, we get it. A virtual machine CPU spike, but what's the big deal about it? It's probably going to recover. But if you look at cloud environments, it's not just about one single VM. It's not about one single web application. It's not about one container that's running. It's a lot more. So zooming in on some of the popular Azure services, like virtual machine scale sets, where you could go like, well, I'm going to deploy my virtual machine. And I know that at some point I might have CPU spikes, I might have memory spikes, I might have disk IO, and I'm going to enable scale sets where out of the Azure platform, it's going to enable automatic expansion of my virtual machine series. It detects CPU load for X amount of time, it's going to add a new VM and another one, right? Where at the end of the day, when you don't see that CPU spike or memory spike or any other spike anymore, it's removing the virtual machines. The same for the web apps. So it's like, okay, cool, Peter, you want to talk about something, but we already have the solution. So what's the big deal? Now, the thing is that it's not just about VMs anymore. If you have Kubernetes, yes, we all know that Kubernetes provides you that high available, scalable scenario. So what's the use case? And let me talk about that. So the use case is chaos engineering. Now you go, okay, you talked about chaos, you talked about engineering, you talked about DevOps. So what's the big deal? Why are we talking about chaos engineering right now? Again, I told you it's like 12-year-old technology, initially invented by Netflix, but heavily expanded and became more popular over the last couple of years. So it looks and feels like, or it's a new technology, but it's not. Or it's like the DevOps evolution 3.0, right? If you're wondering why 3.0, because we started with Agile, then we moved to DevOps, then we talked about site resiliency engineering, SRE, a couple of years back. Where now chaos engineering seems to be the next big thing. Is it going to be the next big thing? I don't know, but I'm going to try and convince you, right? That's it on slides. I know it's a bit more than no slides, but it's because somebody reached out like, can you please explain a little bit about it? So from here, it's only going to be demos. What is Chaos Studio? It's an Azure preview service, but hopefully it's going to go live in, I don't know, the next coming weeks or months, but probably or hopefully more closer to weeks than months. There's not too much information out of the product team yet, besides some upcoming information around pricing somewhere in April. So we can only hope that once we know what it's going to cost to use it, that it's actually going to become available. Now, in short, Chaos Studio is chaos engineering as a service, which means you don't need to install anything. You just enable it in your Azure subscription or multiple subscriptions. And from there, you're going to start building up your testing plan. Because what we're doing with our chaos testing or chaos engineering is on purpose injecting faults. And officially, I would say try to hammer your production environment because it's just more fun than doing something in a test environment. But obviously, it doesn't need to be your production environment. If you run your testing against a dev and test staging environment, and it's still going to help you building out, running a more resilient production environment, that's obviously fine. But it's so cool to just test your production environment. So that's what I'm going to do later on. Next to that, it's not just virtual machines. So the list of supported services is growing by the day, where there's a distinction between agent-based, so technically virtual machines running Windows or Linux, where you need to install an agent and it just next, finish, and then I'll show you. Where next to that, you can run what we call serviceless experiments against anything else that's not a virtual machine. So think of Azure networking. Pretty cool to simulate faults in a virtual network or disabling specific rules in a network security group, or removing permissions against Key Vault, for example, where all of a sudden your application cannot connect to the credentials anymore. So a lot of really cool stuff. The same for Kubernetes, although it somehow based on a virtual machine architecture, it allows you to literally communicate with the Kubernetes API, and from there testing out how solid your server container baseline actually runs. And a few other things, but I'll walk you through. So step one, you define the target, a virtual machine scenario or a non-virtual machine scenario. Next to that, you're going to build your experiment, where an experiment is a sequence of faults that you want to test against your target. You can make it as easy as you can or make it as more complex as you want. So the curious case of CPU, like I just want to test my CPU load, if that's the only metric you want to rely on. Or you're going to build out a sequence of issues, like, well, CPU spike on my web app might cause a memory spike on my database server. Next to that, at the same time, we're going to shut down a virtual machine. We're going to shut down a web app. We're going to shut down a Cosmos database, like triggering regional failover, one of the cool things you have in Cosmos DB. So there's like no real limitation, you could say, on anything that might or could go wrong in your environment. And the whole thing is, again, that you're going to test it out before it's going to happen and identifying like what's the impact on my workload. Does that sound cool enough, Simon, to switch to a couple of demos? I would hope so. Cool. Let's see where we are. Good. So I'm in the Azure portal, and the first thing you need to do is enabling Chaos Studio. So you go to the marketplace, you search for Chaos Studio, you enable it, and that's pretty much it. So no setup required, no virtual machine to deploy, nothing complex, just enabling it, and that's pretty much it for now. Once you go into Chaos Studio, there's two settings, so targets and experiments. Only two steps to cover, right? So you go into targets. Let me actually make this a little bit bigger. There we go. So out of the targets, it's going to recognize everything that's currently deployed in your environment. It's quite hard to test against something that's not there, right? So hopefully it makes sense. So as mentioned, it supports a lot of different resources, and the list is growing every couple of weeks. So there's obviously virtual machines, there's web apps, a popular one, Key Vault, network security groups, virtual networks, and Kubernetes clusters. I think that's probably, and Cosmos database. So those are like 6 or 7 different scenarios. So step one, you select your target. Let's say my Linux Chaos NSG network security group. And from there, you're going to enable it. It's going to run a little setup. We're going to enable, and should take about a minute, maybe 2 minutes. And from there, it's recognized as a target. Let's do the same for a virtual machine that I prepped I got most of my demos already from yesterday, but I like to show you the full sequence, what you have to go through. So there is somewhere Linux Chaos, how original can your demo setups be? And this one will be enabled for virtual machine agent based. Now I'm using the portal. Obviously, you can do the same using CLI ARM templates or pre-injecting the chaos as a virtual machine extension, similar to deploying like Defender for endpoints on your servers or some other agent like Chef, Puppet, Ansible that some of you might be using. So you just inject the package. That's pretty much it. Now from here, there is obviously quite some security in place. So it's going to ask you for a managed identity. So if you don't know what a managed identity is, it's some sort of a service account managed by Azure Active Directory. There's no credentials, no secrets for you to manage. You basically create the identity, and the identity here is linked to the Chaos Studio service. So that's something you need to enable before you're going to take any other steps, right? So I have my PDT Chaos managed identity. It's having necessary permissions on the subscriptions, but obviously you can lock it down on specific resource groups if you want to make it a bit more granular. And then second, it's interacting with application insights using Log Analytics Workspace to keep track of everything that you've been testing on. So your logging information, you could say. So I created my Chaos application insights, just next, finish, and done. And that's pretty much it. So this is probably going to take a little bit longer because it needs to install that agent, but it's only a couple of minutes, right? So while this is running, let me switch. So now we have our targets and it's refreshing. Cool. So I have a few already pre-enabled. I talked about Cosmos DB, talked about Key Vault, and over here got my NSG. It's already enabled, the one I just did like 2 minutes ago. My Linux VM, not yet, but there should be a Windows VM over here. That's already enabled as well. The next step is deciding what can I inject, like what is the fault injection mechanism I can enable. So for each and every of the enabled resources or targets, you can validate what are the actions. Obviously, the actions are corresponding to the nature of the target. Like you cannot shut down a web. Why you can stop a web app, but you cannot just shut it down like you do with a virtual machine, right? Or disabling a firewall rule on an NSG is not working against the VM because it's a VM, it's not an NSG. So there's obviously some logic, but it allows you to not only interact with the Azure layer of the service, but also inside. Like stopping a service, it doesn't mean stopping the virtual machine service. It means stopping a service that's running inside the virtual machine. Like if it's a web app, you could easily say, I'm going to stop like the iis.exe, w3wp.exe, I think. That's the process, or stop SQL server.exe, or pretty much anything else you could think of. So that's where the granularity comes in, that it's not just like, okay, I'm going to stop my virtual machine, I'm going to disconnect it from the network. One of the tests I remember doing years and years ago in a physical environment where it was so cool to literally walk into the data center and then literally shutting down the physical switch or just removing some cables, right? Where now we're somehow doing the same in a virtual environment. Where if I look in like a NSG, you're going to see that the list of faults you can inject are a little bit less complete. Why? Because obviously you cannot do the same inside a VM or against the VM than what you can do with a virtual network security group. So there is quite some logic. You could also manage specific faults that you want to enable or disable for the experiments later on. So we're in step one, enable chaos, create a managed identity, provide permissions. And then step number two, identify the targets. Enable them for service or install the agent. That's pretty much it. The next step is creating your experiments. So what is an experiment? It's where you're going to build up the logic, the sequence of the fault injections. So based on the target, Obviously, you can play with some of the settings. You can make it as easy or as hard as you want. Injecting a single problem like CPU spike, or making it more complete, like I want to shut down my whole virtual machine environment, 5 virtual machine web servers, together with a database server, together with losing the network, and so on and so on. Or even building up a sequence of tasks where it starts quite easy, like there's a CPU spike that we're going to simulate for 10 minutes. Next to that, we're going to inject some latency on the network. Next to that, all at the same time, we're going to shut down our database server, although we're testing against the web server, right? And so on and so on. So easy or hard and anything in between. That's the main mindset. So we have the virtual machine, I guess, deployment worked. Let's check. Yep, that worked. Cool. So I'll show you a live one where the experiment itself is just like any other Azure resource. So it needs a resource group. It needs a name. So I'm going to call this the live CPU spike. And I'm going to store this central US. We're now inside the experiment. You're going to build up steps, branches, and you can combine multiple steps. So the difference is that you can make it again as easy or as granular as you want. So I'm not going to play too much with the labeling. Steps and branches should be quite straightforward. It's mainly about the actions. So we select the fault, and from here, it's going to show us a list of faults similar to the ones we could enable or disable against the target. Now, since it's a virtual machine, obviously over here, AKS is not going to do anything because it's only specific for Kubernetes scenarios. So you need to know at least a little bit what you're doing, right? Cloud service shutdown is what you would use for a web app, like disabling a web app service, like stopping the service, you could say. That's a popular one. Cosmos DB failover, it's about the same. So Cosmos DB database allows you to failover against regions, one of the easiest but pretty cool failover scenarios. It's going to trigger a pause inside your Cosmos DB in the prime region, and then triggering a failover to another region to obviously allow you in your, again, production environment to make sure that your web app or application overall can still connect to the database without any impact. And then the remaining part of the list, so everything from CPU pressure all the way down, with exception of NSGs, are the rules you can, or defaults you can inject against the virtual machines. So I'll start with an easy one, CPU pressure. Simulate CPU load during like 10 minutes would be the default, but you could make this shorter or longer. And what is the level of CPU pressure I want to simulate? Like 95% is probably okay. It's good enough to test your virtual machine, like how solid is it running, but it's most probably not going to blow it up. Now, if you want, you could obviously stretch this to 99%, and then most probably it's going to crash, right? Because that's just what the operating system is triggering. And then next, you're going to define your targets. So this is where I'm going to target my Linux VM, but I only got 2 servers, so nothing blocks you to target this against virtual machine scale sets, targeting multiple servers like web frontends, database backends, middle tier servers. That would be the use case. And that's pretty much it. So you could make it more complete. So let's say, okay, CPU pressure is one, but we're going to add another one, where this time I have no idea what else can go wrong. Linux disk IO pressure. Yeah, why not? During another 10 minutes, where we're going to run one worker load, the file size, like 1 meg, 64K block size, small files, not too important. And we're going to target the same server. So now my disk is going crazy, my CPU is going crazy, and let's add something else, where this time we're going to do network disconnect. From my public IP towards the Linux box, it's going to disconnect the network. And anything else, right? I mean, it's just clicking around. I just want to show you a little bit how it works. where the idea with the step is that everything that runs, oh, it's gone now. Oh, over here. Everything that runs within a single step and a single branch is running all at the same time. So right now it's literally triggering CPU together with disk IO, together with network disconnect during the same exact 10 minutes. Where if you add an additional step, it's going to run after it. So we could add a new step and adding a fault where we can trigger something else, but I'm not going to use it. Let's do stopping a service, the my app, okay, same Linux box, and so on and so on. It was a bit too fast, so I need to come up with something here as well. Oh, let's do a delay. Like there's something going wrong in step 1 for 10 minutes, then everything gets a little bit of space to recover, and then from there we're going to run step number 3 where it's injecting new faults. So this could technically actually simulate like a malware attack or a ransomware attack where something is coming in like a lateral movement, your virtual machine got infected and it's gradually spreading around the network and driving CPU crazy, disk load crazy, disconnecting from the network. And then after a few minutes, it's showing up on another VM and another VM and another VM, right? And that's pretty much it. Now from here, once we have our experiment up and running, let me open. Oh, that was fast. Okay, cool. It wasn't that fast yesterday. So my live CPU spike experiment is, I told you, nothing more than just another Azure resource. And I'll show you inside that resource group. The Chaos Studio. So over here, I got a few that I already prepped. So I got my kill pods for Kubernetes, got my Cosmos DB, and where's the other one? Refresh. It should be, oh, there it was, live CPU spike. Now from here, there's one last step we need to configure, and that's providing permissions from the Chaos experiment, the one that we created, onto the target. So what it means is going into the virtual machine, my Linux box, access control, so it's using Azure role-based access. We're not going to view it, we're going to add it. Where the interesting thing is that the experiment itself, although you think like, well, it's the experiment running the task, it's actually the overall Chaos managed identity running it. So what we need to define here is reader permissions for the experiment to read out information from the triggers. So we specify reader managed identity. And the nice thing is that in that list here, something I discovered only a few weeks ago, there is a specific subsection for Chaos experiments. So it's making it actually quite easy, because before you had to go into that long list of all your service principal managed identities. And if your naming convention wasn't that clear, then it was kind of hard to actually find what you were looking for, right? So here you select Chaos experiment, and it's the live CPU spike. And that's pretty much it. So enable the agent or enable the service, or deploy agent or the service as a target. Next, build up your experiment. And from there, you can run the actual experiment. Cool. So let's do the live one for now, but I'll go back to the ones I already have to just speed up the time a little bit. So from here, we can start it. Technically, you could actually schedule it as well, but I like showing you live. And it's going to start running. So from here, there's not too much actually going wrong. The monitoring is running from within the target, right? So what I did is, for example, yesterday for my Windows VM, I ran it. I'll show you. So I did this last night around my 5 o'clock, and inside the details, there's not too much. So you have the step, you have the branch, and you have the action. Single one, multiple ones, as we configured it, right? Where now, if I switch to my virtual machine, Windows VM, watching over the monitoring, and then 1 day ago, you can see here there's some spike. It's like, well, it's not 99%. Why not? Obviously, because this is the average. So it's fooling you a little bit. So what you can do is go into the actual metrics, where out of the percentage, where's the timing? Oh, over here, pretty cool. So it's showing like 60%. I only ran it for a short amount of time. So I think the numbering is still a little bit off, but you get the idea, right? So that's one scenario. The other one I had, let's see over here, was juggling my pods around in Kubernetes. So there is a process specifically for AKS, and I'll show you what I configured there. So I had one step, one branch, nothing too hard. And out of that pre-built list of fault injections, there is an interaction with Chaos Mesh. Now, Chaos Mesh is an overall open source Chaos product, you could say, for Kubernetes. So it's nothing specifically built out of the Chaos engineering team. They're just reusing what was already available. So even if you have Kubernetes environments across like Azure or AWS on-prem, you could technically skip using Azure Chaos Studio and maybe shifting to Chaos Mesh. But the concept would be the same, it's just a different product. So from here, I specified a scenario like pod chaos. It means that it's just going to stop and start and restart and delete pods and everything that you can do with your container workloads for, again, X amount of time. So it's running for 10 seconds, and every 600 seconds, so 10 minutes basically, it's going to trigger pod failures. So you got your Kubernetes cluster up and running, you got a few pods running as well, and it's going to stop them, start them, stop them, start them. That's the idea. Or technically, it's actually triggering the stop out of Chaos, and it's the Kubernetes API that's actually going to restart it. Where again, you target your Kubernetes cluster. I only have one, so quite easy. Where the outcome of that, if I look in my Kubernetes service, I have my default namespace. That's where you typically have your production containers up and running. And I also created a dedicated namespace for chaos testing. So that's where I would say behind the scenes, inside the chaos testing, that's where it's running the Chaos Mesh open source containers. So you're basically injecting container pods to run chaos testing on your Kubernetes environment. And then out of my workload, I was focusing on this one. So what I configured was, it's a demo sample basic web application, and I defined 5 replicas, which means that whatever happens with my AKS environment, I always need to have 5 pods up and running. We're now behind the scenes out of running that fault injection yesterday. You can see that it restarted all my pods 4 times. So during that 10-minute window, it was like stopping pod number 1, then obviously relying on AKS to bring it up again, then triggering the same for number 2, number 3, and so on, and repeating that sequence like multiple times. So I could try and trigger that again. Chaos, getting lost in my browsers now. Okay, yes. And start. If you're wondering why the fails are there, it's because the role-based access configuration was taking a little bit longer than I wanted to test my runtimes. So that's where the fail comes in. or with a virtual machine. Oh, that one worked fine. I had some failures somewhere else where I did not have the correct permissions. So I forgot to specify the experiment RBAC permissions on the target. But it's quite clear. I mean, the error messages are actually quite clear. So let's see in our AKS, it is running, I hope. Yep, it's still waiting. We're not going to wait for that. You probably get the idea. Then the last one I'll show you, keeping track of time a bit. So I had my Cosmos database where no idea why it gives an error message because it actually worked fine, but I stopped it at some point because I didn't want to wait for it. Where I have my Cosmos database active in 2 regions, West and West US 3, and from there triggering that regional failover. So you built the experiment defining one step or multiple, and one of them was Cosmos regional failover. I didn't have a front end, but out of the Cosmos database, inside the activity log, let's see if we can pull it up. Last 6 hours, last 24 hours. You can see that it's running update database account. And that's where somewhere you can see that here it's running the failover. And obviously, if you do have a web front end, then from there it's allowing you to validate that there is no interruption, or basically almost no interruption. That's a characteristic of Cosmos database. That's pretty much it. I would say that I could squeeze out in like 30 minutes. Simon, do we have any questions like from the live audience, something else they want to look into, or maybe you got a question, something you want to see?
First, I want you to relax, be like, because for the last 30 minutes you've been speaking non-stop. Right? So catch your breath, get yourself a glass of water because slides, then demos, and back and forth, you've been doing a lot. And I think you have covered a lot of, with the demos, right? And that too happening just on the Azure. And a couple of demo demons sometimes, but why not? We have a couple of questions, as you say. Jason says, I'll put you on top. Okay, great demo, mate. Quick question: what advice would you give to organizations that are just getting to explore chaos engineering and are considering using Azure Chaos Studio?
Oh, cool. Well, my recommendation would be just start playing with it. I mean,
Mhm.
like literally what I showed in the last 30 minutes or so, that's like the time you need to get started. So first of
Mhm.
all, it's in a preview for now, which means that some features might change, but I've been using it for probably more than a year now. And any change that got introduced was always an improvement. So it can only become better. It's not probably
Yeah.
losing any of the already existing features. That's one. Next to that, for now, since it's preview, it's a free service. It doesn't cost anything yet. And again, I have no idea what the pricing model will look like once it goes live. But just start playing. I would say think about your workload. What is your scenario, and what are some of the common issues that we're facing? Could be latency, could be stability, could be like unplanned outages, could be the spike usage. Those are like the common scenarios I would say to typically test against. Apart from that, yeah, start small, 1 VM, 2 VMs, maybe
Mhm.
some server service, and from there expand it. Make your faults more complete, because obviously if you test against CPU, but the problem in the workload is not CPU related, your fault injection is not producing the outcome that you're looking for. So I would start small and gradually expanding,
Yeah.
and from there, yeah, seeing what it helps you with.
Thanks, Peter. I think I believe Jason, you must have got your answer. Then we'll move to the next one that we have from Sarah, which she says, "Could ask Jason. I would like to follow along the same question with what types of organization would benefit the most from using Azure Chaos Studio?" I would say everyone, but you're the expert.
But no, I would definitely say everyone because I mean, in the end, moving workloads to cloud, and I remember like years ago when I started talking about Azure, like 2011, 12, the
Windows
marketing pitch
Azure. Let's
for
talk about Windows Azure. Remember, it was
Windows
not
Azure,
called,
that's right.
yeah, Classic Studio.
Like the marketing pitch for cloud at that time was like, it's high available, it's more secure, and it's cost efficient, right? Where the high availability, interesting enough, yes, obviously the platform gives you quite some high availability, but it doesn't always mean that the workload you're going to bring in will accept that high availability. So whether you're like a small, medium company with only a couple of workloads, or you're this big, massive multinational environment, I think testing your environment in any kind of scenario will always be beneficial. And it's not that you need to come up with like complex experiments. Like I'm going to test a whole bunch of sequences back to back. I mean, even triggering like a network outage or network latency or like a um, disk read write spike or CPU spike could already help you quite a lot. And it's what I mentioned before, right? In the physical world, years and years ago, we would technically do the same, like running a failover test from one data center building to another and literally shutting down a data center, like the whole main power switch, plugging it out
Did you
and
really do
validating
it?
like what's going to happen.
Did you
So
really do it, Peter? Running from one data center to the other?
yes, yes, there was one
Wow.
customer I remember, a finance organization in Belgium, where we
Mm-hmm.
literally shut down the full data center. It was almost like literally shutting down the power fuse.
Wow. I never heard that.
It wasn't a
I
good
don't.
failover test, to be honest. It never worked.
You know,
The
I
shutdown
mean,
worked, but the
mhm.
recovering was not as smooth as everybody was hoping for.
Uh,
But it was a fun test to do.
yeah, I don't think I mean the virtual this cloud computing thing makes it pretty easy now, right? It's just a click of a button you can do it. But I'm really fascinated that someone really went to the data center and boom, it's
Mhm.
everything is down.
Yep.
So that's pretty cool. So yeah, so when you say it's in the preview, right? So everyone gets to have this preview, or one with a subscription, or some. Well, how does that work?
Yeah, so it's public preview for a few months already. I think last
Hmm.
September or October, which means that it's available in your subscription to use it.
Okay.
So you just need to probably enable it from the marketplace and maybe registering the chaos provider. But that should happen automatically if you do have the permissions. But that's it. You don't need to install anything. There's no virtual machines to deploy, installing complex software. It's
Mhm.
just next finish, and then it works.
Perfect. It means anyone who's a part of a tenant, right? He can actually go in and do this stuff. I need not take special permissions from my administrator, right?
No. Well, you obviously, I mean, if you got specific policies in your environment where
Mm-hmm.
they're not allowing the provider, then obviously it's
Mm-hmm.
not going to work. But
Yeah.
apart from that, it should be fine. Or like the
Okay.
managed identity, I can imagine that
Mm-hmm.
a lot of admins don't have permissions to
Yeah.
create the managed identity. So you might
Mm-hmm.
need to go back to your security or cloud admin team and asking them to create that Chaos Studio managed identity. So it's not just like, oh, everybody can just next finish and simulate it, right? But that all
Yeah.
depends on how your organization is locking it down.
Yeah, that's great. I mean, this is for the very first time I'm looking at this Azure Chaos Studio, right? I've never seen any demo around it, and you say it's pretty new in the market, right? So that's pretty interesting. Having said that, since it's been in the public review only for the last couple of 3 months, and now this session is actually great. This will help many folks. What are some of the resources? If I missed it, people can go and learn more about it.
Got a slide on that.
Oh, you got a slide?
So
I missed it. I'm so dumb.
no. So yeah, just listed up a few of the resources. So the
Oh.
public docs, I mean, that's where most of the information is available and will be available in the next coming weeks. There is a chaos engineering workshop. So basically, some of the demos that I did are
Mm-hmm.
actually just available on the Learn platform. If you want to expand more on like learning what is the actual use case of chaos engineering, there's the WAF, our well architected framework. that touches on security, high availability, reliability, guidance, best practices, where now chaos engineering is added into it. And then some of the demo scenarios I did are literally available on the Docs website. So there's one for AKS, there's one for the agent. There's another one, I didn't provide the link here, for the Cosmos database for the web apps, and it's expanding every couple of weeks.
Yeah.
So
I
that
think
should
this is
help
a
you.
very great slide. We both should make a funny face, and then people can take a screenshot. Right, because I think that this slides will be very helpful. I'll ask you final question, Peter. As I see, not many people talking about it, right? And you are a handful of people working on it. What are some of the features that one can expect, or maybe if not, what can expect? What are some of the features that you expect the Chaos Studio to bring in?
Well, one of the, I would say, the challenges in the testing is that you can go pretty deep on the virtual machine level,
Mm-hmm.
like killing processes, killing tasks, or spiking not just overall CPU, but spiking like the CPU usage for a specific running process inside a virtual machine. Where once you shift to like cloud services, there's not too many options, because obviously you're communicating with the cloud service level. You're not
Mm-hmm.
communicating what's running inside like a virtual machine, right? So that's one of the comments, or I'd say feedback, that I received from doing similar sessions as this one, but also overall in the trainings I'm providing, where a customer might already use like some chaos engineering product on-prem. We're now to go like, well, I'm moving to a cloud scenario like Azure, and I'm losing
Yeah.
control. So one of the things that I would personally like to see is giving you more granular options against Azure services. Like with Cosmos DB, for now, it's just a regional failover, where
Okay.
it would actually be cool to test against what happens if that record is gone out of my database.
Mm-hmm.
So making or providing more granular fault injection options against cloud services. But since you're not having full control, that's the challenge. I think it's the same with AWS, the same with Google Cloud.
Mm-hmm.
So that's one. And then next to that, actually, one of the things I asked towards the product team is showing you more insights on the testing itself. Because
Okay.
now you run the test, you're like triggering the experiment, but then you still need to go back to the target to validate like what's actually happening. So it would be cool if they would expand, like if you run a CPU pressure experiment, that on the same page that they actually show you like this is the CPU behavior for this target. So a
Wow, that
little
is.
bit more on, I would say, cosmetics, some reporting,
Mhm.
some logging. It's all in App Insight, so
Mhm.
it's not impossible to pull it up, but it's not part of the service yet. So those
Okay.
are like two things that I would like to see coming up once it goes GA.
Now, those are some great feedbacks. I definitely connect the first one that you said, right? The difference between the on-site one and the one with the virtual cloud that we're doing, and the other one is having more insights, right? Those are some great feedbacks. So we'll take one final question that's coming from David quickly. He says, "Do you have any insights either PG will allow for adding custom script as a step to extend the number of fault types we could simulate with, example, is it PowerShell since the list is currently limited?"
Well, so that's something that I would say technically could be done.
Mm-hmm.
So there is an experiment task that allows you to run something inside a virtual machine. So if you have like a PowerShell script that you store in some virtual machine, and from there, I mean, once you know PowerShell, you can trigger Azure interaction and probably trigger a lot more fancy stuff. Um, but that's where I would say you're maybe building your own solution at that time, right? Where it's using a little
Yeah.
bit of like it's easy, it's running as a service, it's next, finish and done. Well, now you're going to start building your own chaos engineering tool using PowerShell. So that's not the
Mhm.
direction I would personally move into. But on the other side, it's just one of the so many options you have. So it could actually be a benefit to make it pretty open. So yeah, good recommendation, I guess.
Yeah. Okay. Thanks for the question, David, Sarah, and Jason. So I keep on saying final question. I'll ask you one final question, Peter. Then I'll let you go. I know it's early time. Apart from all these tech stuff, coding, and with this chaos engineering, what do you do when you get free time? Or what are some of your hobbies?
Well, I told you at the start, right? So,
Mhm.
writing technical books somehow turned into a hobby. It was
Wow.
something I started doing. My first one was 2012 on Exchange,
Mhm.
2013 beta coming up at that time. And I was still traveling for work like almost every week. And there's not too many hobbies you can take with you. Like, I like Lego, I like reading like Marvel comics, but
Mhm.
you're not going to take them with you in your suitcase every single week, right? So that's where like writing technical books was actually like something that turned into a hobby. It wasn't at first because writing that first book was hard, painful, because it's just time intensive and I mean it's an interesting journey, but it was taking a lot of time. But on the other side, I mean, when you're traveling for work, it's boring airports, boring hotel rooms, and then going to the customer. That's pretty much
Yeah.
it. Um, so even for now, I actually shifted a bit from writing technical books into helping other ones, becoming technical authors, providing coaching, doing technical reviewing. So I think that's some sort of a hobby. And apart from that, like now with the weather becoming a bit better and nicer
Yeah.
here in Washington, it's probably going for walking again. So during
Yeah.
winter, I'm slacking a bit, although I shouldn't. But I don't like walking outside when it's too cold or too rainy, which is like half
Yeah.
of the year. In Belgium and here in Washington, it's about the same. But now with the weather getting better, I'll try to start walking again like 2, 3 times a week for a couple of miles. And then, I don't know, maybe thinking about some other presentations or session topics, or I don't know.
That's
That's
good. You know
typically
that
what happens.
when you say it's so interesting that here in India, right, in this part of the world, we don't like to walk during summers because it's so hot. So we actually wait for the winters, like, hey, when it's cold, just go out and walk in the
Uh,
day because otherwise it's so hot.
but yeah,
All right, Peter, I won't take much of your time. It was absolutely great hosting you. Some covered
cool.
some of the great sessions and demos. We'd love to have you back whenever you're available. And thank you so much once again. I'll let you go. And thank you so much, everyone who has joined. We'll see you next week, same time. Until then, take good care of yourself and see you soon. Thank you, Peter, once again.
Cool.
Bye
Thank you,
bye.
Simon. See you next.